Alright, introduction to dynamic braking. Northfolk Southern Locomotive Engineering Training Handbook. Alright, introduction to dynamic brakes. P. Objective. The object of the lesson is familiarize yourself with the locomotive engineer training with the dynamic braking and its operational conclusion. The lesson the trainees will be able to properly apply the relief the dynamic brake of the comprehend with the critical factors involved with the use of the dynamic brake. Trainer will demonstrate with the knowledge and satisfaction over the instructor on the simulator will being able to pass the test and making a score of at least 80%. Probably most of you have one at a time with another put of your car in the second or first gear when descending a hill. You need to do this to retard the car using the braking power of the car's engine rather than using the brakes. You might be compared with the using of the dynamic brakes on the locomotive. The word dynamic braking are familiar to you, but let's briefly discuss exactly what means the dynamic brake. We cover the dynamic braking on locomotive so equipped can be proved extremely valuable in retarding train speed. In many phases of the locomotive, the operation particularly valuable with the descending grade, thus reducing the necessity for using air brakes. What is dynamic braking? The dynamic braking is an electrical retarding device that utilizes the main generator and the traction motor to retard the speed of the train. The dynamic braking is an electrical arrangement that changes some of the kinetic energy developed in the momentum of the downhill force of the moving of the train and electrical energy in a way that is no way connected to the air brake system. The primary advantage of the dynamic braking is the conversion of the kinetic energy of the train and electrical energy with the dissipated with the cooling fan, which is driven by a dynamic braking current with the engine remains idle. The traction motor armature being geared to the axle rotate whenever their locomotive is moving, but during the dynamic braking, the traction motors become electrical generators. The electrical output with the motor armature is connected across the fan cool the resistor grids of fixed ohmic value. The armature output is determined by the speed at which the armatures rotate the track speed by the amount of excitation currently flowing through the motor field of the throttle position. The speed increases above the 25 miles an hour. The effect of the dynamic brake decreases when the locomotive is traveling 25 to over 50 miles an hour. The dynamic braking current is limited to 700 amps, except those units having the high capacity dynamic brake, which will have 945 amps to the dynamic brake. The Max Series locomotive using the AC traction motor, the dynamic braking forces are measured by the dynamic braking effort, which is measured in pounds rather than in amps. Below optimum speed of 25 miles an hour, braking effort declines rapidly on locomotive units equipped with the standard dynamic brake. This because the voltage developed by the motor armature falls below the maximum wheel turning speed slower, even with the motor field with excitation has up to the limit of the throttles number 8. See the chart at the end of the chapter. It can be seen that the voltage drops current with the main can be maintained at a high level, only reducing grid resistance. Alright, R, your extended range dynamic braking. In order to capitalize the advantage of dynamic braking with the majority of the Northfolk Southern Railroad locomotives, are usually equipped with the extended range dynamic brake. With extended range dynamic braking system, that reduce the grid resistance with the steps of speed. Track speed that decreases below 25 miles an hour, allowing the maximum amperage to be maintained until the locomotive slows to about 6 miles an hour. The locomotive units will have the equipped with the high capacity extended range dynamic brake with large grids and increase with the traction motor side with efficiency on former Conrail SC80 Mac units. Utilizing the AC traction motor, the gear ratio of the 83 to 16 maximum dynamic braking effort is realized in the range between 20 to 0.5 tenths of a mile an hour, half a mile an hour. Alright, critical speeds, extended range braking. The locomotive units equipped with extended range dynamic braking reduce the grid's resistance and step to the speed of the 18 miles an hour, 12 miles an hour, 6 miles an hour. Amperage return to the maximum near the speed. Therefore, the max at these speeds, 18, 12 miles an hour, and 6 miles an hour, become the critical, and the brake amperage return to the maximum. See the chart at the end of the chapter below. 6 miles an hour and a half a mile an hour for the SD80. The braking current was dissipated along by the further speed. The reason for the reducing dynamic brake amperage before applying the air brake during planned stop. This will discuss later in this chapter. Flat and tapered dynamic brake. Most Northfolk Southern locomotive units are equipped with what we call the tapered dynamic brake system. The system would load maximum of number 4 throttle starting at 25 miles an hour. Former the Conrail SD50, 60, and 7080 locomotive units have the flat dynamic braking system, which requires number 8 throttle for the maximum loading regardless of the speed. If you want maximum dynamic brake, use the number 8 control position because you may have the locomotive units equipped with flat systems in your consists. Why use dynamic brake? What are some of the advantages of the dynamic braking versus the air brake? The fuel saving probably the disadvantage because of the road locomotive. The units have through more engine speed with the dynamic brake. Those will remain in idle units if the traction motor needs cooling air within speed up. The engine will burn about 5 gallons of fuel per hour with the idle versus about 14 miles per gallon per hour in the number 5 transition in the dynamic brake. Locomotive unit power and number 5 throttle with the air brake applied on the train will burn at least 100 gallons per hour per unit. Multiply this by 3 3 for the fuel savings on the 3 units consist of the power braking versus the dynamic braking. The expected reason for the dynamic braking is train handling slack with both the draft and both forces are kept at the minimum. This helps prevent the broken of the knuckles and drawbars, which with the broken often cause for derailments. Oscillating is less likely to be damaged if the lack of slack action. When you use the air brake to slow the train, the brake shoes come in contact with the wheel, causing friction with the cuff of the heat. The heat causes the hot wheels of the brake shoes, which may cause the wheels to crack or break. It wears out with the brake shoes, and this causes the wheels to wear at the 2 points where the brake shoes is rubbing the wheel and where the wheel is dragging on the rail while the brake is applied. Using the dynamic brake result with extended brake shoes lift and better train handling and less wear to the tear on the shoes, wheels, and rails and cross ties. Or steps to follow when applying the dynamic brake. When ready to use the dynamic brake, crescent hill to reducing speed, reduce the throttle to idle, wait 10 seconds. This will allow you residual current buildup in the traction motor to dissipate. If this is not done, a quick buildup of the braking amperage may occur, causing the slack to run into the run of the rear of the train. Moving the selector to the braking of the B position, establishing the dynamic braking circle with a slight amount of the amperage will amper for the amp gauge. The faster the speed locomotive, the more amperage will show. While using the dynamic brake, the notches on the throttle will be not fill. However, a corresponding position will show the full out throttle indicator. Move the throttle to number 1 position. This will cause the diesel engine to speed up on some locomotive units. It will also cause the braking current to increase. The throttle increase, the braking current is increased. The braking current must be applied gradually. Slack can be controlled by applying the dynamic brake properly. When slack is all bunch, using the dynamic brake to control speed of the train. Controlling dynamic brake with the AAR control stand. With the AAR control stand with the dynamic brake is controlled by the dynamic braking controls instead of the throttle. There is no selector on the control stand. The throttle must be left in the idle using the dynamic brake controller. The control must not be moved to set up until the throttle has been in idle for at least 10 seconds. Restoring power after releasing the brakes. When ready to reapply the throttle, it may be advanced immediately after releasing the dynamic brake. No waiting time is required. Using dynamic brake through the crossover. Moving through any of the turnout or crossovers restricted at 25 miles an hour or less, and use the more of the equivalent at 14 axle extended range. The dynamic brake as reference to the Northfolk Southern Locomotive Series table. The dynamic brake will not exceed 400 amperes or 400,000 pounds of braking effort on the AC traction unit until the lead half of the train is throughout the turnout over the crossover. Exemption. Restriction does not apply with the solid load blocking commodity trains or mixed trains with a solid block of the Vulcan entities on head equaling 50% or more total cars and train. Note, when calculating brake effort, the SD80 Mac units are treated as 9 axles, using dynamic braking and air brake together. Dynamic brake and air brakes can be used together to control speed of the train when making planned stops. When making planned stops with the solid load block the commodity trains using more than an equivalent of 14 axles extended range, dynamic braking is referenced in the Northfolk Southern Locomotive Series table. The dynamic brake must be reduced to 400 amps, less than 440,000 pounds braking effort, less than AC traction units when applying the train air brakes. No, under no circumstances will the independent or dynamic brake be used together. Stopping with the dynamic brake. Locomotive is considered equipped with 6 or more axles extended with the range of the dynamic brake. When the dynamic brake is playing with the stop, the locomotive considered equipped with 6 or more axles extended range of the dynamic brake. The independent brake may be used to complete the stop without using the automatic brake, provided that there are no more than 20 axle locomotive consists including the unit's lower toe. And under this condition, speed is decreased with 3 miles an hour left. The dynamic brake fully applied. Slack is bunched throughout the train, and the train will keep the slack bunch after the stop is complete. The dynamic brake is released. Independent brake is applied. With simultaneously stopping is not being made. The train in the turnout over the cross-out do not apply the solid load bulk commodity trains. Locomotive consists equipped with less than 6 axles extended with the range dynamic braking. When the consists not equipped with extended range dynamic braking. When you use the dynamic brake placed in the plan to stop, the locomotive consists equipped with less than 6 axles extended range dynamic braking. When this consists not equipped with extended range dynamic brake, the independent brake may be used to complete the stop without using the automatic brake, provided that there are not more than 20 axles in the locomotive consists, including engines in tow. Under the following conditions, speed is decreased to 10 miles an hour left, and then with the dynamic brake fully applied, slack is bunched throughout the terrain will keep the slack bunch after the stop is complete. Dynamic brake is released and independent brake is applied simultaneously. Stop is not being made with the train in the turnout or crossover train is not within the limits of the terminal exempt on the main track, and the star means does not apply to solid loaded block commodity trains. Alright, the locomotive brake is not applied along with the dynamic brake. When speed is 3 miles an hour with extended range of 10 miles an hour or less, non-extended range of this is opposite plan with the use of the locomotive. The independent brake with the dynamic brake must be moved to the out position. Independent brake is applied immediately. The dynamic brake handle left in the setup position, given an indication on the recorder tapes having both applied at the same time. Comparison of the amperage of the taper and the higher capacity tape of the flat system with the dynamic braking at speeds of 40 miles an hour, except the max series. Alright, this shows the throttle is throttle 3 is 670 amps, taper 360 amps, high capacity taper and 250 amps flat, throttle 4 is 700 amps, it's 945 amperes, high capacity is 350 flat, 5 taper 700 amps, 945 amps, high capacity taper to 430 amps, 6 throttle 700 amps, taper to 945 amps, high capacity taper to 550 amps, amp flat. 7 throttle 7 to 700 amps, 904 tapers 945, high capacity taper 625 amps flat. Throttle 8 700 amps taper and 945 amps, high capacity taper 7 flat 700 amps. Alright, dynamic braking retarding force. The effective of the dynamic depends on the ability of the traction motor with the acting of the generator to convert some of the energy moved with the train with electrical energy dissipated electrically through the resistant grids as to the heat of the atmosphere. The dynamic braking resistant grids of the maximum horsepower capacity, thus retarding the force available. The dynamic braking will have these following speeds. Will vary with speed. The following amount of the retarding force developed in the different speed with the various type of the dynamic brakes. 4 axles, 2 miles an hour, 4,000 pounds standard range, 15,000 extended range, high capacity range, 15,000 pounds, 6 miles an hour, 10,000 pounds, standard 40,000 extended, 37,000 high extended, 12 pounds an hour, 20,000 pounds extended, 40,000 pounds, 54,500 pounds high extended, 18 miles an hour, 30,000 pounds standard, 40,000 pounds extended, 54,500 pounds high extended, 24 miles an hour, 40,000 pounds extended range, 55,455 pounds, 54,500 pounds high extended, 30 miles an hour, 30,000 pounds standard range, 30,000 pounds extended range, 40,000 pounds, 40,500 pounds high extended, 40 miles an hour, 23,000 pounds, 23,000 pounds extended, 29,500 high capacity extended range, 50 miles an hour, 20,000 pounds standard range, extended range, 20,000 pounds high extended range, 22,000 pounds, 6 axles. 2 miles an hour, 6,000 pounds, 15,000 pounds, 19,050, 6 miles an hour, 15,000, 60,000 pounds, 50,000 pounds, 12,000 miles an hour, 12 miles an hour, 30,000, 60,000, 8150, 18 miles an hour, 54,000, 60,000, 8150, 24 miles an hour, 60,000 pounds, 60,000 pounds, 8150, 47,000 pounds, 50,000 pounds extended, 72,000 pounds high capacity extended, 40,000 pounds, 40 miles an hour, 35,000 pounds extended range, 35,000 pounds of high capacity, engine range 4550, 50 miles an hour, 30,000 pounds short and standard, 30,000 extended range, 34,000 high capacity engine. The SD8 Max series, half a mile an hour to 20 miles an hour, up to 96,000 pounds. Alright, introduction to dynamic brakes. How does the dynamic brake retard the speed of the train? How long must the throttle be in idle before going to the braking? Or just set up, wait up. Why wait 10 seconds before going to the dynamic brake? We'll move with the throttle code to increase or decrease in the braking current. How long must the engineer wait before applying the pull power after coming out with the dynamic brake? When do the automatic dynamic brakes are to be used together? What restrictions play with the extending range of the dynamic brake when making the planned stop of the automatic brake used in conjunction with the dynamic brake? What standard dynamic brake happens to the dynamic brake after it speeds below 25 miles an hour? How can the current be maintained at a high level when voltage drop during the brake? Why are the speeds 18, 12, and 6 miles an hour critical extended range dynamic brakes? Notes. Not more notes. Train handling.